In this project, our very first task was to find actual use cases for semantic stuff, and this is what I'm going to talk about. But before I jump into the use cases, I will give you a little overview about what I actually mean with semantics. There are two terms that are, I think, important to know. There's a lot of more information about this topic, a lot of more stuff to read about, but basically to get the idea of what I'm talking, those two are relevant. So the first is semantic web. It's about having a layer of upon the usual World Wide Web, not for actual people, but for machines, to have data consumable for machines. And it is based on common standard formats. The most important, as I think, is RDF. It's resource description framework with which you can describe, basically anything. The other term is linked data, and this describes methods of publishing structured data and to enable to interlink them. So in this, with this, you use standard technologies such as HTTP and RDF and URIs, and you use URIs to establish connections between entities. There's already a big data web, more or less, which is the linked open data, and you can use this. It's basically, it has a lot of information, like for instance from e-government and university background, but also in e-commerce, I think. In 2014 it looked like this. I guess by now it will probably be a little bigger. So after this short introduction to the topic, I try to show you some use cases that we found. The first one is about business data integration. In e-commerce, we regularly have to struggle with applications that are, or with some applications that each serve a certain purpose in their domain. Like, for instance, we usually have some enterprise resource planning tool which holds several information, but for us most interesting is the basic product information, like SKUs or stock information. And we have a shopping system which actually shows the products to the customer, or displays this on the website and handles the checkout and shopping cart functionality. Then, as you all know, we have a content management system somewhere handling further content or the corporate website and stuff like this. We sometimes have customer relationship management systems which store all data that is related with the customer and all interactions. And lately there developed a new kind of system which is product information management system, which extends the functionality that the shop or the ERP usually already provides to describe products, but to do this for multiple channels, like for instance for the printed catalog or for flyers, and of course for the website and the shop and so on. And besides that, we also have the digital asset management systems, where files are located and assets, along with transformations that have to be done with them, with meta information and so on. Now we have all those kind of systems, and usually they have to speak with each other in some way. And how they speak with each other is usually based on certain business rules, which could look like, for instance, the PIM needs the information, basic product information from the ERP, and assets from the DAM, and the shop needs the product information from the PIM, but it needs also the stock information from the ERP. When actually some customers bought something, there must be some report, of course, to the CRM and to the ERP. And the ERP must be notified on several actions, and the CMS needs to have data from there and there. And I think you get the point, more or less. They need to know a lot of each other, and in reality, those business rules are mostly even more complex, and you get, yeah, something like the spaghetti knot on the right side when you draw it. To solve this, there's currently the approach to just wire the applications directly by using an adapter or connector, or however it's called. So basically extension for one of the system that has to talk with the other system. And the problem with this is that it's introducing new dependencies. So the connectors usually have to know the target system that they are talking with. They have version dependencies on the system where they are to be installed and stuff. So the more applications you introduce and the more connectors you have to use, the more upgrading all the stack will be a very hard task. Another approach to deal with this is to use middleware, which I find in two ways. Like one is the ETL software, which means extract, transform, load. It does exactly this with data. And you have the ESB, it's Enterprise Service Bus. And this is not for the big data movements, but for transactional data, which has to be handled in real time, more or less. I'm sorry. There are affordable solutions out there, like from Talent or Pentaho, that you can use already, but it's usually expensive or time extensive to actually get them running, because you have a steep learning curve with those tools, and there's not too much receipts out there to do stuff with that. Also, the formats are usually transformed from the source to the target directly, so you again introduce dependency between the systems that you integrate, because when you exchange one of the system, you have to change the way the data was transformed. Our approach to this with linked data is to use what we call enterprise data lake. So the idea is basically to put all data into this lake, all business relevant data, in semantic structured formats, which allows you to read out the actual data by semantic queries. You could then use some middleware which actually transforms the unstructured data from the systems like the ERP and the CMS into structured formats and back. And besides that, you can also use other applications which directly work with semantic formats and let them work directly on the data lake. Like for instance, business intelligence software which can give you some insights on your data. Or what I draw on the left side here, content augmentation software, which is another use case that I will describe. Oh my god. I hope it won't. Yeah. I don't understand. Okay, so let's hope. Yeah, so basically other applications can work with the data directly on the data lake. What we get out of this is that we achieve vendor and actually also application independency, because when the data is transformed into structured data once, we can just exchange the application that was actually in this place. Like for instance, we can exchange the shopping cart software and take a new one, and we just need to re-implement the way the data was transformed into structured data and back. So there's no connectors in between anymore. With this also you get a lot more flexible, you get a lot more functionality that you can do with your data. You can actually have more insights that you could never think of before, because all the data was locked inside the applications more or less. It's now all together inside the data lake. And you can have fancy reports with that. Another use case that we see, I mentioned, is content augmentation. And it's about the problem that writing and updating and linking contents with each other is a quite time-consuming process. And it's very crucial for your business to get it out fast, to have it in a relevant quantity, and also in quite a good quality. And also we see the need or the problem that that publishing to social networks and keeping an eye on what is happening in the social networks is quite time-consuming and more or less needs at least one person in the company which does it at least in a huge amount of time. How we want to solve this is to use background knowledge. You remember the data graph from the first slides. To use background knowledge as it's available and link it into the contents that are there. For instance, what you see here is that you have a product description, which is about two cars, two toy cars, and the content is mined for entities which have background knowledge available, like for instance, in this case, James Bond. And you could then use this background knowledge and include it into a part of your website or into sentences and or into the sidebar or actually anywhere where you want it. Eventually paraphrased so that it's not the same wording as from the source. You could also think of automating this process, at least a little bit, where you certainly have to have rules from where the background knowledge should come and for which topics, so that not every entity is enriched with this information. And regarding the social media publishing stuff, you could think about getting background knowledge about trending topics, for instance, on Twitter, and matching those with your actual contents, and at least raising a finger to the editor and saying, hey, there's something out there happening where you have relevant content for this. Would you mind thinking about if you would like to post something? The next step would likely be to automatically post on this, but I think we have to see how the notification algorithms work in reality. Yeah, what you get out of this is that you have a much easier editor workflow. You have less user fluctuation because you have more contents on the site where you can read on. Of course, one of the main goals is to increase the visibility of the website and the shop in search engines. And regarding social media, you have a lot less effort to actually monitor what's going on there. Another use case that we think is interesting is in master data management, where it's about product information management, and the point that concepting and modeling your product information initially is quite time-consuming, and because you have to decide on the categorization of your products, on attributes, on types of attributes, on lists, and to bundle the attributes maybe together into attribute sets and stuff like this. This requires a lot of work, and not only work, but also knowledge of certain fields, like, for instance, content management, marketing, editorial, and also maybe a little bit from the actual field of the product that you're selling. When you do mistakes on that, it can be hard to change that later on, especially when it comes to search engines. And yeah, if you don't measure, for instance, you could never guess why the bounce rate, for instance, on your shop is that high. Maybe the categories didn't fit or something. Our idea to at least help on this is to also use existing background knowledge from the semantic web, and to take basic product information, like for instance the SKU or the product title, and to search the semantic web for products like this, and to get the information that others are already providing. They have to sometimes, or it's a good idea to show product information in semantics formats on the web, because Google is already using it, and probably other search engines as well. So it's a good idea to have it online, and this means we could use it. And there's a linked data set which provides information about the actual websites on the web and what information they actually provide. So we don't need to recrawl all the web, but we can just use this data set which provides information about websites to retrieve sites having information for your product. Also, when you think about that you're not the only one selling this product, you have to have an eye on the market and to see what the others are doing and which product information they provide, and also if they change something, it might be a good idea to notice that. And when you regularly do this crawling, you could just notify the shop manager and say, hey, there's something going on. Maybe you want to do something. What we get out of this is, of course, a reduced amount of time that you need to categorize your data and so on. You don't need this much expertise of your actual products in certain fields, as I said. And also you once again have an eye on the web, more or less, and see what is happening out there. There are 2 use cases left, in case you you were asking, and they go in quite the same direction. So one is about semantic search, where the problem that we see is when you search for terms that are not actually in your index, this most likely won't be found. For example, if we have consider a toy retailer who is selling corgi cars, it's actually the brand. And there's a user coming to his website and searching for Matchbox, which is a common task for common name for toy cars. Then he won't find this unless the shop manager used the keyword Matchbox anywhere in his product description or in keywords or somewhere. The semantic solution to this could once again be to use background knowledge on both on the term that the user is actually searching for and the data and the contents that are indexed, and to use this background knowledge to match both with each other. So with the example, it could look like you query background knowledge for Matchbox, which gives you that it has something to do with toy cars. And as well, you do the same for corgi, and you found the similarity that they both are related to toy cars, and you can happily present your user with your corgi cars. And what is the benefit on this is that you don't have to do this on your own, but it can be automated. So once again, you have less time, and also the quality of the results may be better than before. And when you think of the data lake that I showed you before, you could actually use a lot of data from other sources that you wouldn't have used before, like for instance from the CRM, and boost some results based on data from the CRM or from the ERP, whatever you want, more or less. And in a similar direction, the last use case is going. It's about recommendation engines. you know the related products that you usually see on Amazon or in any web shops, which is also known as up and cross-selling. You can, or you have to actually manage this information somewhere, either manually, so someone has to sit down and to take one product and link it with other suitable products and so on, which is really time consuming, and also changes on this are very hard because you have to go through all the products and do the change. Or you could use some algorithms which are more or less extensive and give more or less satisfying results. If you want good algorithms, good applications on that, you usually have to pay quite a bit. What we could do with semantic solutions in this field is to also use background knowledge to automatically link the data, and yeah, we can actually use the functionality from the semantic search that I just showed, and we can also once again include background knowledge not just from the linked open data cloud that is outside there, but also from our business data that we have inside the data lake. I think the benefits are clear. You get probably better results in the related products, and you consume, or you need less time to actually manage them. So to sum this up, what we see as the key use case, also because it just enables the other use cases, is with the business data integration, because this solves a lot of problems that we usually have with applications, and we can just think of other applications using the data lake and working on it. So the other use cases are interesting for us as well, and I would be very happy if I could get some feedback or some ideas on this. So if you have any feedback, please consider writing me an email, or you can call me if you want, or send me fax. And yeah, thank you. Are there questions? Okay, thank you.
I don't know. No, you're not getting away without a question from me. But
Poor me.
semantics are like my things that I eat in the morning, giving me lots of strength. As you might know, we've been working on the Forget IT project in the last 3 years, and we've created some proof of concepts for semantic annotation T3EE 7.6. So my question would, and I know that we're going to speak to each other, so everybody should be knowing that there's already a dialogue going on, but basically, how much of the things that you have been presenting are either publicly available or can be accessed via your company offerings? So that's a more or less question, or is I was not very listening too much to some details, so excuse me this dumb question.
You're excused. So there's nothing ready yet. The project that I was talking about, the LEDS, is generally about taking existing technologies and to build a stack out of this. with details like, I don't know, I'm not too much into it, but Hadoop and SPARQL Server and stuff like this, and they combine it. And parts of those are already published. There are a lot of literature and talks about this. You can see this on the LEDS website, which is leds-project.de. And we are considering actually providing this as a service later on. So I don't think that we will publish the whole solution once, but the components. Okay.
My question was more like, you know, what can the Tapestry community expect to happen? So this is something that we will certainly talk about.
Mm-hmm.
So we know that there's going to be a new rich text editor in Tapestry version 8 coming up. So we hope to have the semantic annotation been introduced via that editor,
Mm-hmm.
so that at least that entity enrichment that you call augmentation can be assigned or can be attributed to your actual Tapestry pages, so that people that are currently having Tapestry web pages can profit from a better findability by the machines or by the search engines. But this is no SEO, so this is just a short-term benefit that people get from doing that. On the long run, I think what people should really know is that the semantic search that you were explaining, kind of a synonym search, was maybe not a very touching or very striking example, but I'd rather like to make people think in that direction, that it's you want to search about things that you might have a notion about, like to say, what are the projects that I have been working on where material was good, and then you find out, okay, these are all the projects that consist of, that have materials that are wood, and this is product, or something like this. So we really need to continue this education for the use cases, because one thing that we found out in this 3 years research is that semantic web has been explained, you know, yeah, Tim Berners-Lee, well, that's everybody's like kind of getting out of their ears of the people, and they have no real use case for it.
That's the point. Yeah, we had a conference lately with the LEDS stuff. There are a lot of researchers talking about technologies, and we were kind of a seldom guest there, saying, or more or less asking what we could actually do with this. And I think it's important to show the use case, the idea. It's not, for me, it's currently not too much about showing actual results, but getting feedback on how we can proceed on this. And we are willing to contribute results from this to the Tapestry project and to talk on, like, for this, how we could work on this together as a community. So, yeah. I hope your question is answered. Yeah.
We will talk about this next year, and you will be able to use some nice products.
I hope so. Okay, thank you.
Thank you, Christian.